Hi, this is Mr. Manley, and I'm going to look at a non-square linear system. If you've looked at some videos or done some study on solving a system of equations in 3 variables, this is in that family of problems. The non-square element of this, that this is a non-square system, means that it doesn't have a third equation. If I had 3 equations, I would consider that square, I guess that square. So it would be a square system if I had 3 variables, 3 equations. We could go up to 4 variables. If I had 4 variables, I would want 4 equations in order to have a square system. So this is a non-square system, and what do we do with this? Well, in this case here, I simply am going to treat it as the same as having infinite solutions. So I'm going to look at this and say that this has infinite solutions. And the way to think about that is to think about it as if I've got a plane, and then I've got a line that is intersecting with that plane or lying on that plane, and there are an infinite number of points that would satisfy both equations. And again, if you've been following my series of videos on solving systems of equations in 3 variables, you know that we don't just leave it at infinite solutions. We're going to write our solution. So I'll write the solution up here in 3 variables, or the 3 coordinates, in terms of another variable. In this case, I'm going to say that I will let x equal some other variable. I will call it variable a. That variable does not matter. We can use whatever variable we want for this other variable. Something other than x, y, and z is what I want to do. So in essence, I have found x. X is a. So I'll put that in and say I've got x is a. And then the next thing, I'm going to find z, because you can see that that's what's available to me. If I know what x is, I'm going to be able to find z. So I'll find the z, and that will be, I'll just write it out here. Say I've got 4a minus z equal to 0, and then solving for z, I get that z is equal to 4a, right? And then I'll take that and I'll put that as my z coordinate, right? So my z coordinate is 4a, and then finally I would need to find y, because that's the only one that's missing. And notice how I'm showing my work here. It would be nice to show your work clearly like this. I'm finding z, I'm finding y, and then we can look at your work and see what you're doing. So here, to find y, I'm going to use this equation here, and I already know what x is, and I already know what z is, right? So I'll do those substitutions for x and z, and then solve for y. So x, we have determined, is a, and then minus y is what I'm looking for, and then plus 4, and I've determined that z is 4a. Equals 3, and then we will solve for y. So I've got, what have I got here? A, and then 16a, so that is going to be negative y is equal to negative 17a when I subtract 17a from both sides, plus 3, and then y is equal to 17a minus 3. And that's my y coordinate that I'll put up here. I want to show you a couple more things here. Let me write that in. 17a minus 3. Okay, first of all, what if someone started off and instead of taking this case here, so that's how we solve. What if someone had said, you know what, I want to let z equal a. So notice that, so instead of saying x equals a, what if we started off with z equals a? And then we would find z, or find x in that case, and that would be 4x minus a equals 0, so x is equal to a over 4, and then we would go on to find, we found x and z, so we're going to find y, and we're going to, again, we're going to substitute, to find y, we're going to substitute into this equation for x and z and find y. Alright, so there's the equation that I want to solve for y. And I get y equals 17 over 4a minus 3. Alright, so my coordinates now are x is a over 4, that was there, right? And then y is 17 over 4a minus 3, and z is a. Now look at that, I've got this is my solution in terms of a, and I've got this in my solution in terms of a, and those are different. But let's just watch this little check here. If I were to let a equal 0, so let's look at the bottom one. If I were to let a equal 0, that would mean that my y-coordinate is -3, and my x-coordinate is 0. So that is a point, and I tell you, and you can check this, that this point here, 0, -3, 0, will satisfy both of these equations. Okay? Let's look at another point. Let's say down here that I let a equal 4. So that would give me this point, 4. And then if I let a equal 4 here, that's going to be 17 over 4 times 4 is 17, and then minus 3. So that's going to be 14. And then if I let a equal 4 here, that's going to be 4 over 4 is 1. And again, I tell you that this point, 1, 14, 4, will satisfy both of these equations. Good? Now, the thing is, if this is the solution, and it has these 2 points, then if these solutions are the same, this should also have the same 2 points. So let's see if it does. If I do 0 for a, what am I going to get? 0 minus 3 is -3. And then I let a equal 0 there, and I get 0. So yes, they both have that point. And then, what's the other one? Here, look down at the bottom, I let a equal 1, right? Or I think I let a equal 4 actually, but a does equal 1. Like if you need to do it the same, I could say a equals 4 here. So actually a didn't equal 1. Let's back that up. A doesn't, if I get a 1 there, that's because a equals 4. So for this point here, I let a equal 4. So we're going to let a equal 4 up here. And if I let a equal 4 up here, what do I get? Yikes. That's not what I want to do. I don't want to let a equal 4, sorry. If this coordinate, if I want this coordinate here to match this coordinate here. So what do I have to let this a be? I have to let it be 1. All right, so if I let a be 1 up here, then I'm going to have, now what I'm going to have, 17 minus 3 is 14. And if I let a be 1 here, I'm going to have 4. So I've got those coordinates, and those coordinates match these coordinates. Okay? So So this is a non-squared linear system. Let me show you one more thing about this. Okay, so notice that this is another non-square system, and I just wanted you to see this. There I've got a non-square system, and we started off with this non-square system, right? So there was a non-square system there, and notice this was 3 variables and then 2 variables. Well, we can have a non-square system with 3 variables and 3 variables, and it's going to work out the same. First off, we're going to go through our steps as if we were solving a system of equations. So I'm going to number my equations 1 and 2, and then I'm going to look at combining 1 and 2, and let's eliminate the x. So if I take the x, I'm going to have 5x minus 15y plus 10z is equal to 5 times 18 is 90. So here I multiplied this equation by 5 and put that there, right? And then I'm going to bring down the second equation, 5x minus 13y plus 12z is equal to 80, and let's subtract these so that the x's drop out, and I'm going to have 0x, and then negative 15 minus negative 13, what will that give me? That will give me negative 2y, and then 10 minus 12 is going to give me minus 2z, and then 90 minus 80 is going to give me 10. So the equivalent system that I could now write is I could actually use this with either of these 2 equations and write what would be called an equivalent system. So the equivalent system would be x minus 3y plus 2z is equal to 18. I'll take the first equation, and then I'll take this equation that I got through the combination there, and then now I'll solve that system. And now we're back to where we were here, where we had 2 equations, 2 variables, infinite solutions. So that's what I have here. I have 2 equations, 2 variables, so it's going to be infinite solutions, and I'm going to either choose A, let y equal A, or let z equal A, and proceed from there. And I'm not going to work through that because I have just done that on the previous page. But if you have any questions, let me know in the comments, or if you're in my class by email. Thank you.